This is the hood of a old British clock that I bought for restoration. As you can see, the medallion on the right broken arch is missing. I can't find one to purchase, so I'm going to make that medallion. That's the subject of this video, showing the process by which I made that medallion. This is one of the original medallions on this case. It's on top of the broken arch. Unfortunately, there was only one. Finding a replacement was next to impossible, so I decided to try to fabricate one and make a pair. The first step was to lay out a 2.5-inch diameter circle on 12 thousandths thick sheet brass. Second step is to cut the circles out of the 12 thousandths thick sheet brass with tin snips. I'm going to anneal this 12 thousandths thick brass by heating it with a Burnsmatic to a dull red. This will give it an antique finish and also soften it for the spinning process. After annealing, you'll want to put a dimple in the center of the annealed part with a round nose punch. Put your part on a small wood block. Locate the center. Tap a dimple into the disc. That'll be used for locating the part during the spinning operation. For the spinning operation, I have a South Bend lathe. I've turned a hard rock maple block, putting the contour of the medallion as you see here. So what we're going to do is take the blank. The blank will be held against the hard rock maple using a brass plug. On one end of the plug I have a center to go over the live center. On the other end I have a dimple which will be used for forming the center dimple on the blank. Also be used for holding the part against the maple block in the chuck. So you want to carefully center this. Then gently push against the part, and then once it's bottomed, tighten it, lock your spindle. We also have a metal bar in your tool post as a support for the stylus, which is made of oak. I just took an old spindle, ground a point for the first operation. Then I have another piece for getting into the corner during the spinning operation. The first thing we'll do is lubricate the part with a block of paraffin. Then we're going to rotate the part and press. We press with a lot of pressure so that the brass conforms to the backing, which is the hard rock maple backing. will use the second stylus to get into the corner. You can control the form somewhat by the amount of pressure and how hard you push into the corners. Here you can see we have the contour for the medallion, and after this we'll start to put the designs in a different operation. This is the original medallion that came with the clock, of which I only have one. This is a completed medallion made after the spinning operation. At this point, I'm going to take you through the process of putting in the designs. First, we have a semicircle, a little dimple. We have radial marks put in with a screwdriver type tip, and then the final design is a little keyhole design which is near the center. It gives a starburst effect. Here you see 6 of the spun blanks. These 2 are made of 10,000 thick brass. They were not annealed. I used a thinner brass just to be able to get the contour easier. Over on the right, you notice these are a little more brassy colored. I kept the heat on these a little less so that it didn't burn away some of the elements that turned the thing dark. Over here we have 2 of the darker ones. So what we're going to do now is take you through the process step by step, show you the tooling involved, and so that we can get the finished design as you see in this medallion. This is a punch I made to do the semicircle around the outside edge of the medallions. First I turned, on a piece of mild steel, I turned a circle, then just use a handheld pencil grinder to grind away the excess and taper this thing down so it would fit into the contour. The second design in the medallion is a dimple that goes between the semicircles, and here it's a simple piece of mild steel with a little bullet nose. It'll be held in a chuck, as we'll see later. The third design that we'll put in a medallion are these radial marks. There are 90 of them, so we have 1 every 4 degrees. To put those radial marks in the medallion, I ground a piece of 1/8 inch drill rod. First I heated and flattened the end to harden it. Then I ground a screwdriver point and then mounted this thing in a piece of brass bar stock, and it'll be used for the radial marks around the center of the medallion. The final design around the center of the medallion is done with a punch made by circular milling a round plug on the end of mild steel and then tapering it back to give you a keyhole design. This will be used to put the 12 designs around the center of the medallion. In order to hold the part for the dimpling operations, I used softwood, turned a blank to be held in the chuck in the milling machine. On a lathe, I made the contour of the medallion so that it'll hold the part face down for the first operation. When you put the part in a block, you want to orient it so that you can put it back for the subsequent operations. Secure the part to the block with 4 screws. Here I have the block set up in an indexing table in the milling machine. I have the semicircle punch, which will put the design in the medallion. This wood is attached to the punch just to keep it oriented in the direction. I keep it in line with the table. Then I have the punch mounted and the depth set so that we just do a series of punches, punch the semicircle design on the outer edge of the medallion. After we set the depth for the punch and make the first one, we index 30 degrees to punch the second one. That'll give us 12 equally spaced semicircle designs around the outer edge. Hit it a couple of times, index it 30 more degrees. Because you're clamping wood in a metal chuck, it's going to put indentations in the outer surface. So you want to mark the orientation of this so that when you put it back, you can feel where the jaws were and retighten in the same spot. That will keep your part centered. Here you see the part after we put the semicircle design there on the edge. Looking at the outside, you can see that we started to complete the designs in the piece. Here we have the radius punch that'll put this little dimple in between these semicircles. Since there are 12 designs around the medallion, they're 30 degrees apart. The dimples go in between the semicircles, as you can see here. So we move this 15 degrees, and then between each of the dimples, we go 30 degrees again. 5, 10, 15, 20, 25, 30. Here I have the medallion reverse from where it was in the previous operation. We have the good side up, and we have it on a different mounting block. We have the little screwdriver or chisel type punch in, and these spacings are 4 degrees. I'm going to give it a couple of marks. We continue that process until all 90 radial lines are put in the medallion. This is the last operation in forming the medallion. We have a keyhole shaped punch with a piece of wood to keep it oriented properly. We've tilted the table at 10 degrees, set the depth, do a couple of punches to put the first form in. Since there are 12 of these designs pressed into the medallion, we're going to index at 30 degrees, 10, 20, 30. After indexing, we'll punch the second of 12 forms in the medallion. And you continue that process until you have 12, and then that completes the medallion in this operation. The only thing left to do to complete the medallion is to trim the excess from around the edges. You can cut it with tin snips and then either belt sand or file the excess. To mount the medallion on the clock, I simply took a round head wood screw, set it down into the center dimple, and silver soldered it. And I held the screw in a end of a dowel, which I put in a drill press so it would hold the thing perfectly vertical, and then just heat it enough to melt the silver solder, and it's ready to put on the clock. This is the restored British tall case clock. And these are the finished medallions that I made and showed in this video.